Hello, this is Clint Halstead, and this is the second video in a series of an CAD project for a step-up voltage converter. So now that we've got the schematic created, what we're going to do is create the board file from the schematic. So what you do is you click this button here. It says board. It says that that does not exist. Do you want to create it from the schematic? And so what it's going to do, you're going to say yes. It will create what's called a board file. So what we do, you can expand that out a little bit. Now what we want to do is, you can see here you have a board. These are the board dimensions. It's a default board. This one happens to be 6.3 by 3.95. What you can do is zoom in on the corner here, and then at the top right corner over here it gives your X and your Y coordinates. So and that's going to be in inches right here. If you click this button, you can change it to millimeters or mils or whatever you want to do. And right now it's in 0.05 inches. 0.05. And you can turn on your grid as well. You can do dots or lines, and I'm just going to do dots. Now the first thing I'm going to do, you can roll your mouse to zoom in and out. First thing I'm going to do is I'm going to change this to be 2 by 1.5. So 2 by 1.5 inches. So I'm going to right click on the corner and say move until this says 2 by 1.5. There we go. So that's where I want the corner to be, and then I can just adjust the rest of this, of course, to match it. I want it to be square. I'll just left click and then zoom in with my rolling the mouse. That's as big as we really need it for this board. So now I'm just going to start placing my components on here. So first thing I'm going to do is maybe get the input. So one thing you can do is you can say move VN. And it'll grab the VN, because if you look over on the schematic, actually, you know, the VN's over here. So I want the circuit to flow VN and then go through the components and then V out. So I usually try to place my components similar to how I have them on the schematic. It just seems to make everything a lot easier when I do that. Also, I kind of have these in front and behind each other so I can easily click. Okay, so I'm going to put the VN on the left side. Another thing you can do is you can actually highlight this with the eyeball function. If you click on that, it'll highlight it. It tells you down here that that's ground. And then over here on this screen, I don't know if you can see it on the screen, but it highlights it on your schematic as well. Here you can see that that's highlighted. I want VN on top, so I'm going to rotate it. I'm going to say move, and then just right click a couple of times and then rotate that. Now if I click, there you go. If I click that, then that's my VN. Okay, you can actually call that net VN if you want. You can actually come over here and say properties, and you can call it VN. Now, when I click on that with the eyeball, it'll call it VN. And on your schematic, if you want to make a label for VN, then you can go to Draw and then Label. You can click your wire, and then you can put a name VN on there. I'm going to do the same thing over here. I'm going to right click on this out, and I'm going to go to properties, and I'm going to call it V out. It's always good to name those. Edit, and then, or I'm sorry, draw, label, click on the wire, and I'm just going to label that V out. That just makes it a little bit easier. Those are some important wires. You don't have to name all of your wires, but it's good to do that sometimes. Okay, so the next thing I want to place is C1. Now one thing I could do is go over here and just look around for it and try to find it. Or I could just go up here and type move C1. and it'll find it and grab it for you so you don't have to look for it. Rotate it around. Now the idea with this is you don't want your wires to be crossed. So if I put it like this, you can see the wires are crossed in the middle, but if I click it around like that, then the wires are not crossed from this pin to that pin. So you can see if I highlight that net, then it's called VN, and that one is going directly to that one. And you can hit your rat's nest tool to route these air wires. These are called air wires. These are the connections that need to be eventually made in the end. Right now your air wires are all kind of jumbled up because the components are just all jumbled together. Now the next thing I want to do is I want to go ahead and add, I'm probably going to want to add the IC component, IC1. And I'll try to place it 1, 2, 3, 4, 5, 6, 7, 8, just like the part. So I'm going to go ahead and grab this and say move. And I'll place it right here. But the problem is, I'm not going to get to have my wish here on this one because by default these components, even though I've flipped it on my schematic, you can't really flip it in the design. These packages are designed to always, if you look at this tab, and the tab is on the top, pin 1's always to the left. So it goes 1, 2, 3, 4, 5, 6, 7, 8. So you could rotate this part, but you could not, you couldn't mirror image it. Mirror image it would put it on the other side of the board. Which you could actually mirror image it if you want. Mirror. But it would mess up your design in this case because we want everything on the top side of the board. So we're not going to mirror that. We'll just keep it as it is because that's the way that it has been designed by the manufacturer. Okay? So next thing we're going to try to place is R5. So we'll go ahead and say move R5. And basically what you try to do is try to minimize the crossings of these wires. So as an example, I'm going to try to put this where this air wire, notice that this pin is going directly to there, and if I hit that rat's nest, you can see that prevents any sort of crossing. I wouldn't want to take this and put the part like that, for example, because then you have a crossing effect. So I'm going to place it just like that. Now I'm going to go grab the next component would be R4. So let's move R4. I'm going to put that component right there. You can also go to package and you can change the package in the design if you want. If I wanted to have that package, I just click it and it would make it a different type of resistor. This is the stand-up resistor package. This is a flat lane resistor. So we'll just do a few different things. We'll try that out and see how that works. Just to be a little different. Okay, now we'll do L1. Move L1. Oh, this thing is pretty big. Oh, that's not good. So what we want to do with this is, you know, it won't really fit if I put it right here. This shows me that I'm kind of encroaching on this part. So we want to make sure that those don't touch. And I wouldn't get them really close like that either, because a lot of times when you go to build the board, this drawing here may not be the actual size. The component, the real component, may be bigger or smaller. Of course, you could always go into the design and change that, but I'll hit the rat's nest tool again. This little thing's called the rat's nest tool. It calculates the air wires. So I'm going to continue to go around here. I want to place D1. So I'm going to say move D1. So again, you can see where this component is trying to go. It seems like it's trying to go about right there. If I hit the rat's nest tool, you can see that it's also trying to go there. So that's a pretty good spot for it. These things kind of drift out as you start doing the design. Let's go on to the next component. How about C0? So we'll do move C0. And we know that this, eventually we want this to be on the output. So let's try to kind of move it over here on the output. Let's use the routing tool. We probably want to flip that. Okay, because that gives us kind of a straight shot through there. This is going to cause a little bit of a problem, but we can always route those wires through there like that. Now we want to place, we can place C2 if you want. So move C2. And this one just needs to go next to that component. Let's see, where would be a good place for this? We'll try to squeeze it in there. What I'm going to do on this one is I know that this capacitor is smaller. We're going to change this package here. Let's look at this package. I don't think I really want that package that I have. You could change the package to a lot of different things. I'm going to change it to one of these type packages because I know that the package is going to look more like that. So I'm going to move that. So let's select. Let's show you what package I picked. You can leave it the way it was, but I picked this C-pole USB 45181C. So you can go through there and try to find that package. Pause the video if you need to find that package. Now we don't really want to cross anything, so let's try to make it where it's not touching anything. Alright. Now the rest of the components, we have a V out, so we can move V out. Just place it on the right side because we know we want it kind of over there. That looks pretty good because those are not crossing, so that looks pretty good. And the rest of these components, I'm just going to grab them. R1 and R2, they go over by pin 5. So R1, I'm just going to left click that just to show you a different way of doing it. I'll place it right there. Place the other one over here, and then I'll zoom in and kind of move them around a little bit. So R1, if I hit the rat's nest tool, let's see where that's going. 1, 2, 3, 4. And then the other one's going to hit the rat's nest button again. It looks like it's going to 5 through here. If you look at that, this one's going up through there. This direction. This one's going to pin 5. That one's going to ground. Okay, so that's going to ground pin 4. So this side of the resistor is going to pin 4. You can see that right here. This side is ground. If you hit the eyeball button. See there, that one's ground. If you hit this side of it, that's a non-ground pin, and then this side is going to V out. So that's correct. So this is going to V out. So that's pretty good. The only thing I don't really like about this is that this polarity is upside down. I don't really like that. I think what I'm going to do is flip this component so that I have plus on the top. There we go. I want to have the plus terminal on the top. So that's V out. Now you can hit this button right here. It's called Fit. That'll fit everything on the screen. And you can kind of probe around. That's V in. That's V out. Hit your rat's nest button to make sure that the connections look pretty good. Now I think I'm going to be ready to route this sucker. Move stuff around a little bit if you want. Try to just space things out. Really, you want as much space as possible. The more space, the easier it is to route. Even getting things away from the edge really helps as well. Because when things are close to the edge, then signals can't always get around the board. Okay, so that looks pretty good. Everything kind of evenly spaced. Now we're going to go to the routing tool. What we're going to do is, let's see, what we're going to do is we're going to hit the route button, okay, and we'll stay on the bottom layer. We can change the width, we can change our grid to mils. Usually we route in mils. I'm going to make it about well, about 20 mils. That's a pretty good size. A mil is a thousandth of an inch. So let me just show you really quick. I want to route this one. So I hit escape. If I hit the air, what you want to do is hit the air wire. You want to hit the signal that you want to route. Make sure you always go either 90 or 45 degree angles. Usually I do a 45 degree angle type routing scheme. So we can just route this thing, or you can auto route it. If there's some important ones that you would really like to have taken care of, then you can manually route those. So if you want to unroute something, you hit this unroute button and it'll unroute it. You can't delete them. If you try to delete a trace, it'll give you a warning. For example, if I try to route this here, and if I say I don't want it anymore, if I try to delete it, you cannot do that. If you want to delete a trace, you have to go to the schematic and delete it. But on the board level, it's called unroute. You have to unroute it, and then you can hit the rat's nest tool to undo that. Okay. So really, I don't think I really want to manually route this board. I will route a couple of important connections. I'll route this VN connection, this first ground connection. Remember, hit the air wire. Don't hit the pin. Click the air wire itself. Just to show you how you do manual routing, I'll just go ahead and do those just for the fun of it. Now what I'm going to do is I'm going to route everything else using the auto router. To use the auto router, I'm going to first thing I'm going to do is I'm going to put let's see, I'm going to put the width of my vias and the minimum drill. I want it to be like 40. Let's see, I'll do 43. And I think that'll be it. Width. I'll change that to about 24. Okay. Now I'll go down here to auto route. What I want to do is, these are all the layers you can route. I'm going to eliminate the top. I don't want to route on the top layer. I want to route everything on the bottom. And I want to go any angle, so that's the asterisk. Routing grid. Usually I do a 10 mil routing grid. Okay. Now if I select OK, it'll go ahead and route that, and it says 100% finished. Only problem is I don't really like that because a lot of these are really close. It's going to be hard to design. So how do I undo that? Well, let's say that I don't like it. What I can do is say rip up, and then this is a rip up button, and then I can hit the go sign, and it'll rip up all the signals. Okay. So what I really need to do is go to the design rules, and I can change all different kind of design rules. One thing I want to change is the clearance. From wire to wire, I can change that to 30 mils. Or 20 mils, probably 20 mils would be fine. I can change everything to 20. I want to have a lot more spacing. 8 mils is 8/1000th of an inch. That's really close. And I don't really want that because that's going to be really difficult to design. So I'm going to change the design rules here to 20. This is for only if SMD means if you have surface mount pads, but we have what's called through-hole pads. You can see that every time you click these boxes, it shows you a picture of the actual dimension that you're changing. Distance from copper, that means to the edge of your board, is 40. That keeps traces out of the side of your board. From drill hole to drill hole, 8 mils. Let's change that to 15. Minimum width of your trace, let's do 20. Minimum drill, I can't drill 24 mils, that's too small. Let's do 40. Okay, and then hit Apply. Now let's go and reroute all of those traces and see what happens. Now you see that we still got 100% finished, but the spacing is greater. Okay, that's going to help make it easier for you to design your board. And if you don't get everything routed on that level, then you can route some things on the top level. Let's assume, for example, that one of these traces wouldn't route for some reason. I'll just go ahead and delete that trace. What you can do then is go in, assuming that you could not route all the bottom trace, you could go in and remove the bottom and add the top back in, and then you can route again, and notice that now it finished routing on the top level. Okay, but we're going to undo that for now. We'll undo that because ours routed all on the bottom layer. But anyway, that'll be it for now. I'll go ahead and save that. It's called stepupconverter_wired.board, and that'll be the end of the lesson. Of course, you can go in here and add a ground plane. Pretty easy to add a ground plane. You go ahead and click this polygon button. Change the isolate layer to about 30. You can either turn orphans on or not. I'll go ahead and leave them off. Then you just draw your draw around the board. Hit escape. Right click on the edge of that. Go to properties. If you want to make it a ground plane, you can call it GND. If you want to make it a power plane, you can call it whatever the name of your power exists. Oh, sorry. I think you have to hit actually the name. You have to name it. GND. There we go. We named it, and then you can hit the rat's nest tool, and then it shows you what your ground plane is. Again, this was the dimension on the side. It kept the copper away from the side. That was in the design rules. Now you can run a completed design rule check, either Tools, DRC, or you can click this button. And you had your design rule set up. Now you can hit check. And it'll check to see if you've met your design rules. This is having a dimension error. It says it's too close to the side of the board. But we'll go ahead and clear that. We'll approve that one. We'll approve that one. Drill size, I had selected a drill size that was too large, and this package has a drill size that's smaller. We're going to go ahead and approve that. Now, in reality, you may not want to approve that. You may want to go ahead and go change that part, make that drill size bigger, depending on what size drill bit you have. And then you may want to make this pad spacing bigger, because a lot of times what happens is if you have a drill bit too big, you'll completely drill your pad size out, and you will have no place to solder. But assuming that you can get a smaller drill bit, now you've passed all your DRCs. If I hit DRC again and hit check, nothing comes up because it says 20 approved errors at the bottom, and down here it says green. So everything's good to go. And that'll be the end of that video. And I did the schematic, and then this was the board. Thank you for watching.